The old man will. The old man will. The old man will. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds.
Hello everyone and welcome. My name is Nathan, otherwise known as Old Man Builds. What's going on, everyone? Guys, it's gonna be a fun week. Got a lot of stuff going on. What's up, Dispatch? What's going on, Aaron? From one perspective, right? David, what's going on, man? Dude, it is gonna be a fun week. Kind of tired, man. Been up working on stuff for quite a while since this morning. You see the Tesla coils behind me, getting ready for shipment on those things right now. We also worked on the pulse motor. So Mike's Renegade motor, man, you saw it there on the thumbnail. Man, we're getting somewhere, aren't we? The Bedini motor is almost done. The coil's done on it. The wiring's done on it. Man, it looks beautiful. Here, I'll show you a picture. Oh, let's see. Right here. Look at that. Nice, clean, the way it's supposed to be. We put in the rails just like Bedini did. I got the coil wired to it now, and everything's done nice, man. We tried to make everything as best we can. You see all the neons in there, man. it's it's been a process, I'll tell you that. It takes some time to kind of lay it out and make sure you do what you want to do and get it in the right spot. Other than that, man, I think it came out great. Just takes a little extra time, you know what I mean? But I think it's well worth it. So we got that one. I think that's pretty cool, man. And then let's take a look. This right here is, I don't know if this is going to come up right. No, of course not. It's off to the side. This is the Renegade pulse motor that Mike builds. So you can see the two piezo buzzers. You can see the bridge rectifier there. We have the sensor there. I did the coil yesterday. One of the things that I know we're going to run into a problem with when we first started is the center of the coil. And I wanted to put the rods in just like the Bedini motor did. Although I know we're going to have to space them out eventually, I just wanted to see the reaction of what it does. Again, better off doing it and finding out, and then we can switch it later. One thing I might build is a PLA core and just big enough for the rods to fit in, and then leaving space in between every one of them. I think that might be neater than to try to tape every one or to shrink tube every one. And fitting it down the center would be a heck of a lot easier. So just a little change in pace in what everybody else does, and I think that's going to work out perfect for us. But again, we'll try the normal procedure first and see how it works. So we're right on track. We got a couple more parts. Again, I need to replace the board, get it to look nice, paint it up, do things like that. Put the coil in position, put the sensor in position. We're going to talk to Mike over at Faraday Research and see exactly where we need to put everything at. Where the piezos go in line, he did the Renegade, if you remember, probably about a year back on the show, and he showed how everything works. So we're going to reference that quite a bit, and we're going to set up the circuit the exact way he did. Probably one of the coolest things, man. So yeah, that piezo, that barium titanate, man, that's what you want in there. It's going to amplify that core and get it to saturate quicker, which again, with the rods may be a bad thing. So we'll have to watch it, like I said, but it's a 2-pound core. We're actually, I think it's 2.2 on the core, and it was 1.8 before the rod. So I think, and that's in pounds, we're going to be right close to where we need to be either way. And there's simply just a single wire in there at what 24 gauge, and then a 26 gauge trigger wire are the two wires going into that one. So, man, we're getting somewhere. And then this week we have to order more stuff. Again, we're going to continue the builds. We're going to start testing here on the SG motor probably this week. It should be finalized, and we'll start the testing there. We'll move on to the Renegade, and we'll put a video together on how we built it, what it does, and things like that, and just put out a, just show you how the thing operates and stuff like that. In the members section, we'll put all the measurements and everything for everything in case you wanted to redo it. But I'll be honest with you, if you just simply ask, I'll give you all that stuff anyway. I just like to put out stuff for the members so that they have it. You know what I mean? They tend to be the ones to rebuild all this stuff anyway. So, but the information's free, and I'll put it out there for everyone. I'll try to put it in some of the videos as well. Anyway, that's what's going on between those. One of our next builds, and I'm going to show you this right here. And Mike did this one as well over at Faraday Research. And let's see if I have it right here. I believe it's this one right here. This right here is Mike Faraday's miniature version of the N machine. So as you guys know, they did the N machine with Mercury. I don't have any access to Mercury. If we do, we might be able to run it on there. On this, I think I'd be fairly safe with it. But this is a miniature version of the N machine, basically a monopolar motor, and we're going to get mostly amps out of it, which is exactly what I want. You see, we learned a long time ago that we can convert on DC from amps to volts. And that's exactly what we're going to do in this motor. We're going to prove out everybody's theory on how to do it. We're going to make sure it works. Again, if I can come up with any Mercury, I can put it on both sides like Bruce did, and we'll find out the special effects of it. So that's up to, whether we can get any or not. So, but the main part will be done. I already have a motor in line right now. We got the magnets already set, so I can order those this week. And then I'll make all the STL files like I usually do. That shouldn't be that hard. Basically motor control going into it, and then pick up an amp meter on the way out so that we can just see and check those, and we'll put a voltmeter there so we could check those as well. But I think, guys, we're gonna have a set of machines here. So as we look at all this, obviously we're getting a little bit into the motors and stuff. I think following back up with that, maybe some Don Smith is one of the next builds I want to do. And what was the other one? I keep wanting to call it the Comanche. I know it's not that. I can't even remember the name. Starts with a K, and it's basically like a Don Smith device as well. But we're going to be doing those, guys. So, what's up, Traveling Fools? What's going on, Yanni? Yeah. We're going to get into a lot of this stuff, guys. So we have all of it. I mean, that's kind of the goal here, isn't it? We want to build everything and have it ready to go so that we can start testing everything that we can and see where it leads us. Because I think we're going to get down to the final answer here with all of it by the time we're done in this year. Is how does everything really work? How does the energy actually flow? I know we have the RAV and stuff like that, and we're working on stuff with that. And it's kind of like a skip to the end when you look at it. My goal is to go back to the beginning and teach everything, show everything, and let everybody understand it. With somebody who's done it in this modern day, some of these builds are over 10 years old. You know what I mean? At this point, so nobody really understands them all that well. So, or they get a bad grainy footage from 10 years ago, and it just kind of sucks. So if we do it modern day, build them, learn, fix them, whatever we got to do, I think it's going to be well worth it, man. So Yeah, those are the projects going on right now. We're going to be working on some of the stuff for the member section, guys. It's been on my desk. I haven't been able to get to it yet. Like I said, I've been working all night getting these Tesla coils or all morning, getting them set up, get ready to ship. And as soon as I get that done, I'm going to start putting files into the member section. So, I mean, we had a lot of cool stuff out here, man. Bernie's been over here taking all kinds of videos of things. He's got potato power going on outside. We had it in here, man. We got a lot of voltage from that. I'm actually surprised. The only thing was it wasn't as useful as we wanted it to be. There was no back brake or how to say a magnetic field or anything like that, like a stopgap to push the power. So it was there, it just had no push to it. It was almost like you had to pull it like a one wire energy where you have to pull it through the system. And I think that was probably one of the things we should have tried. Maybe put it on a PMP or something and try to pull it through that way. Probably my mistake in that. But I definitely charged up. I charged capacitors. Um, Probably didn't have the right ones in line with it. We'll have to buy a bunch more capacitors. That's for sure. That's one of the things in the future, guys. Going through different capacitors. Which one do you use? Why do you use it? Um, I want to get bare and titanate capacitors, and then I want to turn around and get the blue ones, which are the aluminum capacitors. And then, I'd like to, at some point, build my own capacitor, and resistor, and then, you know, a diode, and just show how they're all pretty much the same thing. It just depends on how many wraps around it you have. And then that way everybody can understand it, but we'll do it a little bigger so that everybody can see exactly what's going on. So, sorry guys, I'll put this thing even closer. I guess you guys are not hearing me all that well. I'm surprised actually. Anyway, that's what's going on, guys. We got a lot of work that we did. Um, you know, I don't want to say this. The Bedini motor, all I have left on it is a shaft to put in, and then that's done, and we're testing. And then like I said, I want to spiff up the Renegade, the pulse motor. And then, guys, we also have another one that we're going to do. We're going to do the Utron, the floating Utron. That one's going to be cool. Okay, it's got two magnets on the base. It's got the shaft in it, and then it goes up to four big magnets, man, really big. So Papa Bale's going to hook us up with the STL file for that. We're going to order the magnets accordingly, and we're going to build it just the way he did it, man. I think it's one of the coolest things ever. He took this Utron. For those of you guys who remember the Utron coil we did, he took that and he put four neodymium magnets in there. They're 1 inch by 1 inch by 1 inch cubes, and those things, man, it's uh, it's just stellar, man. He's got four of them in there. I'm surprised he didn't smash his fingers 500,000 times doing that. Anyway, it goes in the center of the Utron, and then what happens is it builds a magnetic field under it, and then he has two magnets under there, so it stays right up above it. So it's just levitating right there, and then it spins, man, and it looked beautiful. And he made a pulse motor out of it, man. That's one of the ones I want to do. Shout out Papa Bale, man. Totally awesome at doing this. So like I said, guys, there's not going to be many more things. Capanzi was the name of the device that we're going to do as well. That one's on the list. It's basically just kind of like a Don Smith style coil, and it's multiple coils, and it's run out of a ZVS. That should be fairly easy for what we're doing. It may just take a day or two just to order the right parts for that one. I think the wire choices, I have most of them here. It's going to be the little details that they put into it, but we can definitely do that. One of the things I want to do, since it is so sunny out, is I want to get to the outside and put a rod in the ground and pull the energy right out of the ground. If you guys remember, Inventor 3 did this, and Paul went over and he had a rod in the ground. I think it was a well rod. We'll see if we can. I don't think we have anything here like that, but if we could pound 10 feet into the ground, man, or something like that, that'd be awesome. What I'm looking to do with that is something real simple. Just put the Tesla coil right over it. Just a 2-inch diameter Tesla coil. And what we're going to do is we'll see if we can pull energy out of it. He was able to pull energy and put it into capacitors, just as like an earth battery or something. And that's one thing I want to see if we can do. And then we're going to set up a rod to go up high so that we can see if we can pull it out of the atmosphere. If we can get both and get them to work, then we can pull off, the Tesla tower and stuff like that. I got a tower out there we can use for that, and we can start setting that kind of stuff up. I just need to make sure we can get both energies, and I just want to show that you could put it right into a capacitor right away, and I think that's going to be way awesome. Now, I don't know that I can get the pole way up there. However, there are high voltage lines that run over my backyard. So, yeah, maybe for a couple seconds turning it on, maybe a minute, maybe they won't mind so much. But, you know, it's just to prove a point and show how things work. So I think that's well worth building out as well this year. I mean, we're in a place now where we can start building a lot of stuff here. My garage is finally like a studio where we can get everything cleaned up and taped and filmed and done right. So that's exactly the path I'm going on. And then we go outside and do that. Pull the energy out of the air, pull it out of the ground, show Earth battery. Man, it's not too many channels going to have as many inventions on it that we will, but we're definitely going to get through it this year. We started off real good with the SG, and that's going to be out in video soon. Man, I'm excited. There's a lot of stuff that we're working on, but everything's coming to fruition right now. Since Bernie's here, we're two of us working on it. We got a lot of stuff going. You guys can't see it, but in front of me, he's got his whole monatomic setup, running. There's a cool experiment he's got going on with aluminum and copper. And you can see it every day, all the stuff that pulls off of it. And he got some pictures for me so I can show you guys that. And I'll put together a video on it, and we'll do a time lapse. That thing's beautiful, man. So it's really interesting the reactions you get out of some of this stuff. So that's going to be really cool, man. We haven't dealt with that a lot on this channel. I'm excited to see how it works. And then Sean got us that microscope so we can see every bit of the monatomic as it lays out. That's amazing, man. I can't wait to see that footage. So, and then Bernie and I are going to start with the RAV and do some experiments with that. We're going to put it in water, man, and see what we can do. I mean, some of this stuff doesn't like to run in water, but that we're not going to give it a choice. So, we got a lot of cool water experiments coming up. And we're going to do a live show. So not this week on Traveling Fools on the Friday, but the following week, I'm going to go straight into the lab, man, do it the Find Out Lab. And we're going to do some cool experiments. I'm going to run ACs on my Tesla coils. Then we're going to go into DC water. And yeah, man, we got some really cool stuff coming up, man. Should be a lot of good content for everybody. Yeah, you gotta would you get there, Dennis? You just got a big diode for making a ZVS DC flyback RAV maker. Nice. There you go. Yeah, well, with that setup, man, you gotta remember the RAV, it's a little bit different of an animal than everything else. So you gotta get it in that purple look, and then once it starts to take off, it'll go to yellow, and then boom, you'll be right into a RAV. That's going to be awesome, brother. I can't wait to see that, man, on your channel. That's cool, man. While you're testing it in the yard, monitor those potato batteries. You saw that, huh? Yeah, Bernie's been putting up the stuff in there, man. We took potatoes, and we wanted to run a Tesla coil on them. So what we did was we kept cutting them in half, man, and kept hooking in the anode and cathode to each one of them, or not anode and cathode, but the I don't know what they're called, just a positive and negative into them.
Cathode.
That's okay. Anode cathode, Bernie says. So we kept hooking everything in, man, and it kept giving us the power. I think we got what up 12 volts, close to 13, and then we got four. No, excuse me, 1.82. Was that on our amp, something like that? And it was actually doing good, man. I thought it was going to turn on the Tesla coil, being that it was only a 5 volt trigger, but it didn't have enough pressure to get there. When we hooked in a little light, we saw why it just wasn't pushing enough through it. The power's there, it just doesn't push it. So yeah, we'll have to draw it out of it next time. Probably be better make suction in there and pull the power. Might be a little bit better. Anyway, yeah, we got the Bernie buried the potatoes too. He's growing them out back to you. It's totally awesome. Love that, man. Absolutely love it. We're gonna put that in on our channel here pretty soon. It's been, like I said, it's been sitting on my computer, man. I haven't been able to get to it yet. So I've been doing other things. So that's going on there, and you know what I mean. We should have a lot of different experiments, man. Stuff we haven't done before. That's kind of cool, man. We got the collaboration going on, and you get to see everything now. So I'm really excited about that. Oh man, I keep hearing clicking. I think that washer's messed up or something. Oh, whatever. I'm sorry. I probably got some noise in the background too because my 3D printer has been going off. We've been running them kind of nonstop to get everything done. So, but it's been worth it. I answered that in the first part, Paul. The Bedini project's almost done. I just got to change the axle. That's it. I need to make one trip to the hardware store, and Bedini motor's ready to test. All the wiring's done, the coils in it, everything's done. Um, I believe I think that's it. I don't think there's anything more I can do to it. To be honest with you, I need two little pieces on the side. That's it. But I can get those at the hardware store just for the main wire connection to go in, so it's easier to connect on them all the time. And that's it, man. That one's done. Yeah, the Spuds Cat Bank. You saw that one, huh? Yeah, I'm gonna put that on my channel too, man. Yeah, Bernie and I did good on that one, man. We made some voltage out of it. I wish I did better. You know what I mean? So, yeah, that one was cool. We'll have to do an orange cat bank too, because we got the oranges in the back. So that'd be pretty sweet as well. We got to figure a way to get that energy though. How to make it usable. You know what I mean?
Pull it out.
Yeah, pull it out. I think that's the way to go. So there's that going on, man. Love those kind of experiments. They're easy to do. It's stuff you do in high school. Remember that? So, well, for those of us who paid attention in high school. So, yeah. Anyway, yeah, we got that going on, man. And hey, Bernie, can you bring that over here? That the one that looks like a hook, is that able to be moved?
This one?
Yeah.
Yeah.
Oh yeah, you guys gotta take a look at this, man. Look at that.
Complete white coating, yet it's copper. Oh, here we go. Here we go. Ooh.
There you go, man. It looks like it's cotton or cloth or something, man, but I know it's not. He had it in there with aluminum.
Aluminum copper right there.
That's so cool, man.
It's alive. It's alive. So we can look at that under the microscope as soon as it's dry.
Yeah, dude, that's radical, dude. That's so awesome, man. Yeah, that's what we've been watching the reaction and how it sits above, like there'll be a bottom part of water, and then the reaction will sit right above, so all that white you're seeing right there, and then they'll be empty. You know what I mean? Or the stuff will be moving, and at the very top, there's like a foam layer that goes to the top until it starts breaking down, man. So That's cool, man. Yeah, it's looking real good, man. He's got another reaction he started off in there as well that he's getting going, and he's been pulling out the monatomics as he's going and cleaning it up, man. Definitely an ace at this thing, man. I wouldn't know where to even start yet. So, except for just putting things in there and putting voltage on them, but knowing me, it would be super high voltage. I don't understand 5 volts. It doesn't compute in my brain apparently. So, yeah, that's gonna be good, man. And we're planning a big lab, dude, experiment. So I kind of want to just put it out to a bunch of channels, man. If you guys are interested and want to link in that day and show stuff to your channel, man, let me know. I'll put out a post on it a couple days before we do it. I just want it to go out as many people as humanly possible that wants to watch it. You know what I mean? Because I'm going to be doing a whole bunch of high voltage stuff in there and a whole bunch of Tesla coil stuff. It's going to be just off the chain. So the more, the better. So that's going to be awesome, man. I'm looking forward to that. Dielectric coating on the copper. Yep. Okay. One wire electrolysis. Well, we could, but that wouldn't even be a problem, man. That'd be easy. Um, Set up a Tesla coil to run all night, man. Those things run forever. Let's see. Yeah. Let's see what they do afterwards after he pulls a bunch of stuff off of them, man. Before they die, we'll have to hit them with some high voltage or something, just to see if we can't break them. That'd be cool, man. Yeah. Yeah, I'm working on a circuit now, so that's a frequency circuit that we could put out there on the channel as well. I know a lot of people ask on the high voltage changing the frequency, so I'm working on that circuit. I have it run. We just haven't tested it yet. That's going to be pretty cool, man. And then we're going to make a circuit just for the Rodin coil on basically put it into run. How do I say this? The neodymium magnet. It'll just run it all day long. We'll just put the right frequency into it and set it, and then you can plug it into any Rodin coil and it'll work. So, because it's that one right there is basically just the correct frequency and the correct voltage, and you get that magnet running all day long. That's pretty much with any coil, by the way. I've plugged that thing into geometry coils. I plugged it into a number one of a Tesla coil. I put it on every coil that I had, and it worked. So it doesn't matter if it's bifilar or something like that. By the way, that's another thing we're working on is a bifilar coil. People are asking about that. They don't want to see a speaker wire stacked one that's stuck together. They want to see the dielectric between the two. And that's exactly what's on the build list. It's on my list to buy when we do the end motor, the end machine. That one's next in there, man. So within the next 3 months, man, we're gonna have so many different projects that are finished. It's fun, man. It's gonna be real fun. So yeah, we got the Tesla coils, man. We're gonna get back into some one wire energy with that. A lot of the old videos that I did are kind of spur of the moment stuff like that. There's no real understanding to them. And in looking back in it, we're gonna remake some of those videos. So if you want to know how to put your Tesla coil in your wife's casserole dish with a bunch of mud and you want it to light up 3 feet away, I'm going to show you exactly how we did that one. One of the other ones that people really like is when we take the Rodin coil or pancake coil, and then I put the wire down the center of my Tesla coil and pull the wire out and show you that there's energy still in the other coil for at least 30 seconds to a minute. People want to see that one again. So we're going to do that one while Bernie's here. So that's going to be just awesome. And then I'll go over and I'll hook a light bulb up just to a wire, just a fluorescent, man, and put it on a plug and put it right into the dirt and turn it on. and we'll have the light bulb light up. I'll get a lot of people confused on that one. Watch, but that's going to be epic when I do that one. So I've been working on some of this stuff, guys, so I can get it cleaner, so I can do a better job of showing you guys this. And then I haven't worked too much with my bipolar Tesla coil, so we're gonna have to start doing that too. Um, just a matter of, you know what I mean. As we get them, we're gonna do them. And I'm checking my list off of everything I wanted to do. I made a list last year, and I pulled a whole bunch of money in, man, from selling Tesla coils. And you guys helped me out on the show. I put it all together in an account so that we could basically just buy products this year and build everything. So it's been kind of scarce on my channel for videos, but it won't be that way for long. Trust me, it's going to pick up big time. What's going on, Omega? Nice to see you here, man. So yeah, that's pretty much what's going on here. I mean, it's kind of a slow week other than that, man. Well, not for me, for maybe for everybody else, but I've been. I think I work till 1 o'clock in the morning one morning, and then the next night till 10 or 11. Guys, I'm usually in bed by 5 o'clock at night. So 5 6 o'clock. So I've been up late, man, just putting in the time to get everything done. So yeah, we've been pushing the envelope on everything, man. I don't know how much more I could push, except for we got another one too that they came up on the list was the Tesla coil that is a Tesla style coil with open air gaps in between the windings. That one's going to be cool. So Bernie's going to try to hook up with the guy that showed it on Tesla Tech, and we're going to try to get that one completed as well. Yeah, we were on Tesla Tech last night with Steve, and I gave a presentation on resonance. I don't know if everybody saw that, but um, we just we did a live demonstration of it. Here was the cool thing, man. I had all the number two coils out there, right? And I put them in a geometric pattern of a square with the trigger driving coil being on the outside of that. What actually happened was I coupled the capacitance between all the coils, and then I was taking my driving coil and turning down the amount of energy going in and see how much I can get it down with any part of the light still on, right? So my trigger voltage is 5 volts for my whole thing to turn on, right? I turn around and got this thing down to 3 volts. The only way it gets to 3 volts is if I was able to couple the energy between each coil in capacitance and drive it back to my main system and put it back in like a snubber circuit, which I have, and it goes back in and it recharges the capacitors that are in there that we use that we switch on and off. Yeah, they get charged back up through that circuit, and they give you more voltage going in. So your meter on what you turn on and push into the system down at 3 volts. The amount of energy in the system is much higher. What it is we're just coupling capacitance, and we did a live demonstration on it, man. Totally epic last night. In doing that, we talked about it, and then we showed it live, and yeah, it was pretty cool, man. So I'm really proud of that. It was one of the few times that in the afternoon half the stuff didn't work, and I'm fiddling with it, and then right before showtime, man, it turned on beautifully, and everything worked out, and everything turned on. So, and I could even tell I was a bit out of resonance when I did it. You would see the light, the little black spots in the light, and I don't think the camera picked it up that well, but they were right there, which meant I was a little bit out of resonance on some of it, which means I just barely got into the field of the coupling. So I could have put a lot more into that and probably driven that thing down to 1 volt. That would have been epic. But I'll be happy with 3. You know what I mean? I'm happy with 3. Getting it down to 1 volt or less is an amazing feat if I can get it in resonance, in perfect resonance. But one of the main things that came out of that is a geometrical pattern I put the number two coils in. I don't think people realize how important that was. It was coupling between them because they're all perfectly spaced apart. So it was like, I want to say this, the dielectrics of each one of them in between the coils were interacting like this. So it was coupling the capacitance throughout all of the coils together. So they acted as one big capacitor in air instead of capacitor to the ground. So that was pretty special, man. A totally epic moment, man. So it's one of those things that if you understood what you were looking at, you're totally amazed. If you're not, it just looked like a couple of light bulbs that lit up. But that was awesome. Yeah, right on. Thank you, Dennis, man. I appreciate that. Yeah. Dude, I try hard to get some of this stuff out there, man, because like a couple of days ago, there was a guy on the Tesla Tech thing, and he was talking about doing something like that. And I go, well, I've done that on my channel. Let's just share it, right? So that's what I did. And then also the one wire energy, I'm going to be bringing that to Tesla Tech to show live. So if anybody watches that or gets the behind the scenes to it, you're going to see me over there live at Tesla Tech, man, doing the one wire energy, putting the water, the rod in the water and showing everything that it does. So that's going to be cool, man. That's going to be something special to look forward to. And then we're actually going to go up here and visit Steve in the next week or two and help him put stuff away at his place and get to kind of look at some of the cool inventions he has up there. So we'll put that on the channel as well, man, when we go up there. That'd be kind of neat. And then we're going to visit Courtney Sam's here pretty quick and see his giant Tesla coil out there, man. The thing was awesome last time. We're going to get it caught at night. So, yeah, dude, my schedule for the next 2 months is like booked to get all this stuff done. So, nah, it's pretty cool, man. Let's see, you had some great effects. Oh, man. We'll have to take a look at that, Dennis. So, give me 1 second, and I will pull this up. All right. Let's see, it's probably on the sort section. Oh, here's something. Huh. There you go. Listen to the sound of this thing. It's going crazy in the ear. Dude, that thing is cool. Is that a spark gap in there? Yeah, it's got to be a spark gap, is what I'm seeing. Not a neon, right? Yeah, that's a spark gap. That's where all the sound's coming from. That's cool. Let's see. Sprouts. Were you making sprouts or did this would come from your Tesla coil? Nice. Yeah, the sound was coming in pretty harsh. Radiant sprouts, yeah, nice. Growing them with this Tesla coil. Only way to go. Love it. Oh, let's see what we got here. So this is oh, hold on, it didn't. Did you go back to it? There you go. So is this them right here? Yeah. It's just growing little seedlings right there with it. Oh, you can get the voltage on the outside. It's just finger. Yeah, let's see this. Oh yeah, you can see the voltage touching on his finger, man. That's what he's growing the plants in. That's kind of cool, man. Heck yeah. You guys said bottom right video. Uh, voltage grows plants, man. Okay. Let's see. He's got the voltage stuff there. I think I saw this one. What's this one? Want to lock up on me? No? Is that going to show me anything on that then? There we go. Something going on there. Looks just, there you go. Oh, look at the colors in that. Yeah, it's striping it like a candy cane, huh? Dude, that's awesome. Dennis, you're doing great work, man. Huh. Let's go back and look at that again. Yeah, you can see the colors. Look at that. Oh, yeah, look how dark that comes in, man. Oh, dude, that's like totally epic right there. Yeah, you see that? Yeah, Dennis figured this thing out, man. I think it was a standing wave, yeah. I tend to agree with you there. Yeah, look at that. Fluorescent white bulbs are not supposed to be that color. They got a dark part, it's almost red, and got a pink part in there. That's spark gap, man. That's what he's got going on. That spark gap that changes things. Was 528 hertz. Wow, that was a low frequency to get there too. I bet you it's that. See, when you spark it, man, it changes the frequency. It takes those the high amounts of frequency and brings them down. That's cool, man. I noticed that when I did the replication of what you're doing there. I noticed that was the case in it. It was how many times it sparked, and that continuous spark, that repetition, was what was doing this. Yeah, I'll let it play. Everybody can see it. That's awesome. That's so cool. You can see it on that one too. It's still going. Huh. Look at that. High voltage fingers. Oh, dude, you can see the pattern coming out of that thing. One of my circuit ideas, really? Dude, that's pretty cool. Right on, brother. Glad I could help. You deserve all the credit, man. You built it. So, heck yeah. That's so cool. We never see that on the internet, man. Yeah, you got everybody beat there, Dennis. That's for sure. Let's see what other ones you had here. There's another one. Okay, I don't think that's. There we go. Now playing. Yeah, this is really cool. Well, there it goes. 7.83 hertz, huh? Oh, well, look at that. Hold on. Look at that. Oh, dude, that is totally epic. Look at that. The cloud forms. Dude, there is cloud forms in there. .83 hertz, huh? Watch this, guys. It looks like there's clouds forming inside the fluorescent tube. Oh, look at it. Slow down. I saw blue in there too. Oh man, that's totally epic. Yeah. All right, man. We're gonna have to pause it. Take a look here. Ooh, yeah. Look at that. You can see the gas inside of it. Oh, that's sick. Oh, look at that. Oh, you can see the gas barely lit up there. It's dark, huh? Look at that picture. That's awesome. That kind of looks like Sean's glass when he gets it in the high voltage, man. The rab going. Real super bright, man. Oh, you can see the gas in there. Ooh, look at that geometry pattern. Do you guys see that? I know it's a little hard to see, but you can see at the very right side of it, of the light itself. It's a total geometric pattern in there. There's like diamond shapes in there. Okay, hold on. I'm going to have to take a shot of this, man. Just do a screenshot here. Okay. Let's see. Yeah, take a look at that. You know, I saw this in the oscilloscope. You guys remember when we did the oscilloscope and we took it out of focus and it started making geometrical patterns in it? Well, now it's making it in the gas. You can see squares all day or diamond shapes, however you care to look at it. It's all in there. It's literally structuring it. Dude, Dennis, you gotta take some photos of this, man. Take the footage and photo it out, man, and show everybody. This is you got some cool epic stuff going on here. Yeah, he is, dude. Definitely crazy work. Yeah. Well, you're running at Schumann's resonance. I mean, that's in itself, man. When you get something like this, it's telling you that there's a pattern behind everything. Yeah, it's grid-like, that's for sure. Oh man, that's awesome. That's awesome. Matrix plasma. I'm there with that one, man. Definitely there with that one. Yeah, Dennis got going on right there. All right, let's go back to the We'll go back to the video and see what else we could see. Keep slowing it down and pausing it. Oh, right there. Right there. Oh. Come on, Nathan, pause it. Let's see how it breaks out. Yeah, that's cool, man. It's going to gas on the end and stuff too. Hold on. Let me get a good picture and I'll screenshot it again. Oh man, look at that. That's epic on the colors right there. You can see the blue in there, the blue, the white, the pink, the whole spectrum's right there. Hmm. All right, let's take a shot of this and we'll see what it looks like up close. Yeah, look at that. You can see the gases in there. It's almost like if you look at the left of it where it goes lighter, it's almost like a little tornado in there. It looks like it's spinning the gas. Oh man, that's cool. Well, I don't know either. I've never hooked up the sound circuit to it. I'd love to do it though. Yeah, look at that. You can see all the different colors in it. It almost looks like something you can see in space with plasma. You know what I mean? Way epic, dude. Way cool. All right, let's go back to the video again. Yeah, there it is doing the same thing. Man, it's crazy. Half the lights lit up and the other half's not. That's way cool, dude. All right. Let's see what else you got going on in here, man. Saw the sprouts, saw everything else, man. The video was awesome, Dennis. Okay. All right. Yeah, dude, way cool. Could be a shutter defect. Well, yeah, it could be. You never know. But he's been dropping that plasma down with the low frequencies, man. And that changes things. It goes into geometric structure and why it happens that way. Yeah. Kind of gets to the heart of it, doesn't it? When you start seeing stuff like that, you start to see, hey, ancient ancestors, what were they looking at? Well, if they were looking at that, they saw the geometric structure everywhere, didn't they? Oh, let's see. In the shorts, there's a triangle wave video. Hold on, let me see. Let's see, triangle wave right there. Okay, give me 1 second. I'll pull it up. Yeah, yeah, it was, dude. I agree. Look at that. Shocking his finger. Nice. Yeah, I agree with you, man. That was totally cool. Dude, just playing with the plasma. Just like me, man. It's exactly what it does. Nice. All right, man. All right, guys. Dude, that's just so cool, Dennis. You're way ahead of a lot of people, man. That grid structure was just unbelievable, man. That's uh that's something, we're gonna have to keep with us forever. So I'm gonna have to try to replicate what you did, and see how it turns out, because that's really cool. Anyway, guys, look, I'm gonna call it early today. I know we usually do about 2 hours. We're only gonna do an hour today. I've been super busy lately. I got a lot of projects that need finishing up. Um, Hopefully, let's see. I'm hoping by Friday we get a glimpse of the SG and it running for the first time. So wish me luck on that, guys. And then the pulse motor, it'll be a few weeks before I start putting out information on that. But we got a lot of work to do on the Bedini anyway. But yeah, we're gonna have some cool stuff. Thank you for sharing, Dennis. I do appreciate that, man. It's totally awesome. So, guys, wish me well, and then like I said, this is going to be an epic month, man. We're going to have a lot of stuff, and I'm going to try to space it out so that we can see all the individual stuff. I'm curious to see what that SG does, to be honest with you. Everybody says that over Unity, not over Unity. Well, if I can charge more batteries than the one that I deplete, then we're doing good. That's a good start. Now, does it restructure the battery? I don't know. You know what I mean? Everybody says it does. I'd like to see how. You know what I mean? So, anyway, with that said, guys, I want to thank everybody for watching today. Sorry for the short show, but I got a lot of work I got to still finish up today and get things done. So, with that said, thank you very much, everybody, and have yourself a great day.
The old man will. The old man will. The old man will. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.